An important idea in trigonometry is learning about the notion of radians. So when we're looking at triangles, right? Let's say, just for simplicity, we have a right triangle. So this is a right triangle. Okay, and let's say we have 30 degrees here. We've been thinking a lot about triangles in terms of degrees and side lengths and stuff like that, and specific values that are only kind of there for that specific question. So for example, if we had this side length to be 4, that means that this would be 2 root 3, right, using our special triangles, and then this would be 2. So this triangle is like our 30, 60, 90 triangle magnified by a factor of 2. So 30 degrees is really the same as pi over 6 radians. Okay, and by the end of this video, I hope that you understand what this means. So what is a radian? Well, radians help us graph trigonometric functions. That's their primary kind of purpose. So if we have 30 degrees, we can't really convert that into something we use in the real world other than how we explain to people like shorthand. So for example, you'd say like, oh, I'm running up like a 10-degree hill, or I'm sliding down a 40-degree slide. But we can't like take an input of degrees and output like a real distance, because it's like it doesn't really work like that. So what radians are is, if we have a circle like this, right? So let's say we have a circle like this, right? And let's say we have a radius, I'll call it just r. Okay, and let's say we have another kind of line attached there. So this angle theta here, okay, this angle theta is going to produce, like, say this angle here was 1 radian. So theta equals 1 radian. The shorthand for radian is just like rad or rad. So 1 radian would produce an arc length right here. Okay, it would produce an arc length of the radius itself. Okay, so 360 degrees, that's kind of the whole span of this entire triangle. 360 degrees is equal to 2 pi radians. So one way I like to think about it is the circumference of a circle is 2 pi times the radius. Okay, so 2 pi is just a constant, and the radius is just the radius of the circle, right? So if we take our radius, which is this r right here, multiply it by 2 pi, we're going to get the circumference. Well, that fits nicely with this idea that a circle is 2 pi radians, because if our angle here, theta, is 1 radian, and that subtends an arc length of 1 radius, then that means if we have 2 pi of these radians, so if we have another one here, right, there's another one. If we have another one here, there's another one, and we just keep adding them up, right? After 2 pi of these radians, right, after 2 pi of these radians, so if these are all the same angle theta, right, if we just keep adding up these arc lengths, eventually we're going to get the circumference. So the circumference of a circle is 2 pi r, and like I said, that fits nicely because if we have 2 pi, so 6.28, which is impossible to do exactly, but about 6.28 of these angle thetas, that's going to give us the total circumference of the circle. So basically 1 radian is just the angle at which it produces a subtended arc length of 1 radius. Okay, so for example, if we had a circle here, and the radius of the circle was, I don't know, 3. Okay, well, if we had an angle of 1 radian, So this is our angle here of 1 radian. This would also be 3, and this would also be 3. So the arc length in here is going to be 3 units, which is the same as the radius. That's only when our angle is exactly 1 radian. Well, what if our angle wasn't 1 radian? What if it was, say, 2 radians? So that would be maybe something like that. Actually, probably be something like that. Okay, so this is 2 radians. Okay, well, if we kind of split this into 2 here, we imagine this was 1 and this was 1. This would be a radius, and this would be a radius. So if we add those two together, we know the radius is 3 itself. So if this is 2 radians, that must mean that this subtended arc length is 2 times the radius. So this is going to be 6. Right? It's the same idea if we had, right? It's the same idea if we had, I don't know, 3 radians. If this was 3 radians, right, so it's just under pi radians, then we would get a subtended, this was 3, subtended arc length of 9. Right, so the circumference of this circle is really 2 pi times the radius. So 2 pi times r, which is 3, so this is 6 pi. Well, 6 pi, if we put that in our calculator, right, 6 pi, that's going to be 18.85 approximately. So we can't ever do this exactly right by using this method over here. But let's imagine we just added, say, well, 2 pi radians is 6.28, so let's do 6 radians. Okay, that's going to get us to about here. Okay, so if we started here and we did 1 here, 1 here, 1 here. Okay, so if we did 6 radians and we kind of increment it into 1 radian each, so this is 1, 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 and this is 1. If each of these is 1 radian, well, this will be 3, 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 and this will be 3. So we have 6 3s, so if we add all those up, the circumference, excluding this area right here, will be 16 units. Okay, and then this little bit right here, that's going to be the 0.28 left over, because 2 pi is about 6.28. So this will be 0.28. Right, so we have to do 16, which is all these 3's added up, plus 0.28 times, well, that actually, let's see here, 0.28. We're not going to get an exact value, but you kind of get the idea, right? So if we just keep adding all these up, we're going to be able to get close to what the actual circumference is by using the radian method. Okay, so how do we actually convert to radians? So before I showed you that 360 degrees was equal to 2 pi radians. And what I did here, I'm just going to clear it up. So this wasn't actually 16, this would be 18, right? Because we're adding up all these 3's. 6 times 3 is 18. That's why I confused myself there. So 18 units. But if we want a more approximate answer, we're just going to go plus the 0.28 radians left over times the radius. Because 1 radian gives us 3 more units to add to our circumference. So 0.28 times that 3 is going to give us what we're adding. So it's going to be 18 plus 0.28 times 3, which is 18.84. Okay, and of course pi is irrational, so we can't get an exact answer using this method, but approximating it, it's super, super close. So that's really what radians are doing. We're saying however many radians we have, that's going to give us the total circumference of the circle if we multiply it by pi, or if we multiply it by r. So that's why the formula for the circumference of a circle is 2 pi times r. Because 2 pi is just the number of radians that are in a circle. And if we multiply that by the radius of the circle, we're going to get 2 pi times these radians incremented in 1, right? So 360 degrees is 2 pi r. And if we think of this in an equation, we can immediately divide it by 2 to simplify. And I don't know why I wrote r here. So 360 over 2, that's going to be 180 degrees. So 180 degrees is equal to pi radians. So see how these 2's cancel? And so just start to familiarize yourself with this. If you see kind of, if you see these quadrants like this, right? If you see these quadrants like this, and let's say our terminal arm, right? We started on the positive x-axis like this, and we're rotating over 180 degrees. It's good to start thinking of this in radians. So you could say, okay, this is pi radians. Okay, and maybe if it didn't go all the way, maybe if it just, I'll redraw this, maybe if it just kind of extended to the 90-degree mark, you could say, okay, well, if it started here and it kind of rotated up to there, well, if 2 times that, right, if we went all the way to 180, that's going to be pi. Well, then this must be pi over 2. And that's exactly right. So the conversion all starts with this. It's 180 degrees equals pi radians. So let's say we wanted to figure out how many radians 30 degrees was. Well, if we want to go from 180 degrees to 30 degrees, we have to divide by 6, right? So if we divide by 6 on the left, that means we have to divide by 6 on the right. So 30 degrees on the left will be equal to pi over 6 radians. Okay. What if we wanted to figure out how many degrees 3 pi over 2 radians was? Well, if we know 180 degrees is equal to pi radians, if we want 3 over 2 pi, we have to multiply this by 3 over 2, and multiply this by 3 over 2. So 3 over 2 is like 1.5. 1.5 times 180 is going to be 270. So 270 degrees is 3 pi over 2 radians. Okay, and if you think about it as an equation, you can really solve for any value of radians or degrees. Like, let's say you wanted, I don't know, 5 radians. You would have to multiply this, like if you wanted 5 radians, you have to multiply this pi by 5 over pi. Right, so those would cancel. On the right, you would have 5 radians. And on the left, you would have to multiply this by 5 over pi. So 5 times 180, I don't know what that is, 5 times 180, it's going to be 900 over pi. So 900 over pi degrees is equal to 5 radians. So this isn't like super, like it doesn't have a ton of utility to do, but the main idea is think of the equation 180 degrees equals pi radians, and then just go from there. So that's kind of the basic conversion. I hope that made sense. I hope you have more of an understanding of what radians are actually doing, what they are, because they are really useful. We're going to be able to graph sine, cosine, tangent functions, as opposed to just doing questions involving degrees. So now that we know what radians are, we're going to be able to plot them and use them as inputs, as opposed to just figuring out side lengths or doing arbitrary questions that don't have a ton of meaning to us. We can actually find things that keep occurring. We can see patterns in graphs and stuff like that. So hope this was helpful, and I'll see you soon.